Again, exciting or fascinating world chemistry. We're looking at EMF and Gibbs free energy. We're going to start the reviewing over half reaction. So here's an example of half reaction. Please do that on your own. We'll go over in class. All right, now, EMF stands for electromotive force. It's the potential difference between the two electrodes that produce the driving force that pushes the electrons. That's basically going to give us our voltage that we need. Now, in order to do that, we have a standard reduction potential. That's found on page 857. I'll give you a link in the Google Classroom so you can see it. To find it, it is the E prime, which is the EMF, is equal to the standard reduction potential for the cathode minus the standard reduction potential of the anode. All right? So let's look at a problem. Copper ion plus zinc gives me copper plus zinc ion. We're going to split that into two half reactions for zinc and copper. So copper is going to have 2 electrons over here, balance it up, and zinc's going to have 2 electrons over here to balance it up. Since I'm losing the 2, the zinc is oxidized. Since I'm gaining the 2, the copper is reduced. Okay, again, my reduction potential, standard reduction potential for the cathode. So we'll do copper, and for the zinc, the reduction potential of the anode. We look at the chart. It's 0.34 volts for standard reduction potential of copper. Standard reduction potential for my anode is negative 0.76. We don't multiply here. Put the values in. 0.34 volts minus 0.76 volts. We get an answer of 1.10 volts at the total voltage for that cell. All right, so we'll do this one in class. Copper dichromic acid plus iodine ion gives me chromium 3 plus ion plus iodide. All right, so one other thing we're looking at real quick, and that's Gibbs free energy. They measure the spontaneity of a reaction. We talked about earlier, we talked about thermodynamics. Our value again is delta G, but the equation this time, delta G is equal to negative N times F times E prime, where N is the number of electrons, F is a Faraday constant, 96,500 joules per volt mole, E is the standard EMF. So let's find the Gibbs free energy for fluorine oxygen voltaic cell. If we look at our standard reduction potentials, here is a page with all the reduction potentials. We find that the reaction of fluorine, F2 plus 2 electrons, gives me 2 fluorine ions. For water, that's the oxygen one. H2O gives us 4H plus 4 electrons plus oxygen. So fluorine is the reduction since it's gaining. Oxygen is the anode because it's losing. So we get 2.87 volts and 1.23 volts. We subtract those, we get 1.64 volts for my standard. So to find Gibbs free energy, again, my equation here is delta G is equal to negative NF E prime, all right? N is negative 4 because it was gaining 2 and losing 4. Common multiple of 2 and 4 is 4. The F is still 96,500 joules per mole volt. And the voltage of standard we just found is 1.64 volts. My volts cross out, and I get an answer of negative 633,000 joules per mole, but people don't usually like that big a number, so we'll make it negative 633 kilojoules per mole. And if you remember, we talked about it earlier, negative Gibbs free energy means the reaction is spontaneous. So let's do this one together in class. Find the Gibbs free energy for the silver tin voltaic cell. And then we'll do this one afterwards on your own. Any questions, let me know. That's good. Take care. Be good. Bye.